Okay, continuing with examples of and probability questions and the multiplication rules for probability. Suppose 60% of all people like broccoli. I have no idea if that's true. I just made that up for the sake of this example, but assume that that is the correct percentage. So in probability terms, that would mean that the probability of any individual liking broccoli is 60%. If you invite two friends over for dinner and serve broccoli, what is the probability that both of them will like it? Now, I'm assuming that this is independent, like they're not your friends because you all bonded over your mutual love of broccoli or something. But if they are truly independent, so whether or not one of the friends likes broccoli has no effect on the odds of the other friend liking broccoli, then the probability that both of them like broccoli, friend number one likes it and friend number two likes it, would be, we got to use that multiplication rule and multiply together the probability of the first friend liking broccoli times the probability of the second friend liking broccoli. So 0.60 times 0.60 is 0.36. If you like percents better, you can say there's a 36% probability that both of them will like it. What if you invite three friends over? What's the probability that all three will like broccoli? That means that the first one does, and the second one does, and the third one does. So that would be 0.60 times 0.60 times 0.60, and that comes out to be 0.216, or 21.6%. Now, before I give you multiplication rule 2, that applies when the events are not independent, I have to explain some notation that you will see in that rule. P of B, and then there's this vertical line looking thing, and then A. So the A and the B stand for events, things that might or might not be true, and the vertical line stands for, well, conditional probability, which means the probability that the first thing, B, occurs if the second thing, A, occurred or is true. So you would say this is the probability of B given A, or the probability of B happening if A happened. So the second letter after the line, that's the condition. That's the thing that, okay, assuming that's true in that case, under that condition, then we want to know what's the probability of that first event being true. So the first letter, the B in this case, is what might or might not occur if that condition is true. For example, suppose I use the letter A to stand for is an American citizen. So that's somebody being an American citizen. Some people are, some people aren't. And E stands for speaks English. Some people do, some people don't. Then P of E given A would mean the probability of a person speaking English if they're an American citizen. So if someone's an American citizen, in that case, what's the probability that they speak English? Well, pretty high, close to 100%. Most American citizens do speak English. But what if I turn it around and write P of A given E? That would represent the probability of somebody being an American if they speak English. So if all you know about somebody is that they speak English, under that condition, what's the probability that they are an American citizen? I don't know, but it's a lot less than 100%. Just because somebody speaks English doesn't mean they're an American citizen, because lots of other people around the world speak English too. People in England speak English. People in Canada, people in Australia, people in all sorts of places speak English as a second language. So just knowing that somebody speaks English, there's not all that big of a probability that they are an American citizen. So it does matter which one is the condition, And which one is the thing that you're talking about? Okay, what's the probability of that being true if that condition is true? Now, multiplication rule 2 that you can use when you're talking about events that are dependent says P of A and B equals P of A times P of B given A. That is, the probability that A and B both occur is equal to the probability that A occurs times the probability that B occurs if A occurred. For example, there are 10 M&Ms in a bag, 6 blue, 3 green, and 1 red. If you draw 2 M&Ms without replacement, and that means that after you pull the first one out, you do not replace it before pulling out the second one. What is the probability that both are blue? Again, there's that word both, so this is an and question. I'm asking, what's the probability that the first one you pull out is blue and the second one is blue? So because this is an and question, we're going to be using that multiplication rule, but they're not independent, so we're using that multiplication rule 2 that I just showed you. We're taking the probability of the first one being blue times the probability of the second one being blue if the first one was blue. So first of all, what is the probability of that first M&M that you pull out being blue? There are 10 in all. Out of those 10 possibilities, there's 6 ways of getting one that's blue. So the probability of the first one being blue is 6 over 10. Now, suppose that did in fact happen. Under that condition, where the first one you pulled out was blue, now you're pulling out another one. And in that case, the probability of the second one being blue is 5 over 9, because this time there's 5 ways of getting one that's blue out of the 9 that you have to choose from. So we got the probability of the first one being blue, 6 over 10, times the probability of the second one being blue if the first one was, 5 over 9. And then when we multiply those together, on top we get 6 times 5, which is 30. On the bottom we get 10 times 9, which is 90. So 30 over 90, that can be reduced to just 1/3. The numerator and denominator are both divisible by 30. So in lowest terms, the probability is 1/3. As a decimal, that would be about 0.333. So you got a 1/3 chance that both of the M&Ms you pull out are blue. What's the probability that both are green? Same kind of question. This is the probability that the first one is green and the second one is green. And so we will be taking the probability of the first one being green times the probability of the second one being green if the first one was green. So the probability that the first one is green would be 3 over 10. 3 green ones out of 10 in all. Now, under that condition, if that actually did happen, what's the probability of the second one being green? That would be 2 out of the 9 that are remaining to choose from. So 2 over 9. And then when we multiply 3 over 10 times 2 over 9, we get 6 over 90. In lowest terms, that would be 1 over 15, or in decimal form, that would be about 0.067. What's the probability if you draw out 2 M&Ms without replacement that both are red? Well, if we do this one the way we did the other two, we break it down into the probability that the first one is red and the second one is red. So we take the probability of the first one being red times the probability of the second one being red if the first one was. What's the probability of the first one you pull out being red? 1 over 10. And then if that happened, in that case, what's the probability of the second one being red? Well, that would be 0 out of 9. And then 1 over 10 times 0 over 9 would be 0 over 90, which is just 0. Bet you didn't see that coming, right? Well, yeah, I did, because if there's only one red M&M in the bag, there's no possible way that you could pull out two M&Ms that are both red. And when something can't happen, the probability is 0. Now, if we were drawing with replacement, then it could happen. It could be that we pull out a red one, put it back in, pick again, and we get a red one the second time as well. So if we were drawing with replacement, the probability that both of the M&Ms we pull out are red would be 1 over 10 times 1 over 10 again. That would be 1 over 100 or 0.01. It still wouldn't be very likely, but it could happen. Now we're back to drawing two M&Ms without replacement. What's the probability that the first is red and the second is blue? So we're taking the probability that the first is red times the probability that the second is blue if the first is red. Probability that the first is red would be 1 over 10. The probability that the second is blue if the first is red would be how many out of how many? 6 out of 9, 6/9. And then when we multiply, we get 6 over 90, which is 1/5 or 0.067. So coincidentally, that's the same probability as getting both of them green. And what's the probability that the first is blue and the second is not blue? That would be the probability of the first one being blue times the probability of the second one not being blue. Probability of the first one being blue, 6 over 10. Probability of the second one not being blue, if the first one was blue, well, how many not blues are there? 4. Out of how many in all? 9. So 4 over 9. And when you multiply, you get 24 over 90, or 4/15, or 0.267. Now some practice with conditional probability questions. Mrs. Smith has 7 daughters. If we select one at random, what's the probability that she has brown eyes if she has black hair? Notice what that's asking. It's saying, what's the probability that the daughter we select has brown eyes if she's one of the ones with black hair? So we're only focusing on the ones with black hair. If she doesn't have black hair, we don't care about her for this question. So if she has black hair, that means she's one of these 4. And out of those 4, what's the probability that she has brown eyes? Well, I see 1, 2 that have brown eyes out of the 4 with black hair. So the probability of having brown eyes if they have black hair is 2 over 4, which is 0.5. What's the probability that she has black hair if she has brown eyes? So this time having brown eyes is the condition. If she has brown eyes, that means she's one of these 2. And in that case, under that condition, the probability that she has black hair is 2 out of 2, or 1. If she has brown eyes, she must have black hair. Next question. If we select one at random, what's the probability that she has blonde hair if she has blue eyes? So which are the ones that we are considering? Which ones do we care about? We care about the ones who have blue eyes. Out of those, if we know we're dealing with one of the ones with blue eyes, what's the probability that she has blonde hair? How many out of how many? That would be 3 that had blonde hair out of the 5 that have blue eyes. So 3 over 5 is 0.6. And what's the probability that she has brown eyes if she has blonde hair? So if she has blonde hair, she must be one of these 3. And out of those, if that's true, what's the probability that she has brown eyes? Well, that would be 0 out of those 3, or just 0. The probability that she has brown eyes, if she has blonde hair, would be 0. Because if she has blonde hair, she definitely does not have brown eyes. Okay, we'll be back in part 3 with some more examples and some more kinds of questions to consider.